Okay, so we talked a little bit about what a rational number is. A rational number is a number that you can express as a fraction of two integers. And when we're working with radicals, if we can't get rid of that radical, it's not rational. Okay, um, and when we're simplifying fractions, so we've talked about multiplication. Now we're going to look at division. We're simplifying fractions. There's just a general rule out there that you can't end up with a denominator as irrational. You have to make your denominator a rational number. So that's why we say we're rationalizing the denominator. The numerator, the top part of the fraction, can be irrational, but we're always going to make that denominator a rational number. And there's a way to do that, and we'll look at that today. So on the first one, we have the square root of this fraction a over b. And in terms of rules, what you're allowed to do, just like we were able to split up products, we can split up division as well. We can make this the square root of a over the square root of b. And by doing that, sometimes it's a nice thing to, it helps us in the process here, okay? Other times we want to go back and just make it one fraction. For example, I'm not done with number 1, but if you look at number 2, this one, I want to leave it like that because we know what 8 divided by 2 is, right? So that's the square root of 4, and we know the square root of 4 is 2. And so sometimes it's nice to just leave it like that, because if I split it up, I'd have the square root of 8, which is irrational, and have the square root of 2, which is irrational, and make it more complicated. So sometimes you want to just work with the fraction there. Sometimes you want to break it up like this. Okay? So with fractions, you're able to change the way fractions look without changing the value of the fraction. We call them equivalent fractions. So 2/3, for example, could also be written as 6 over what? 6 over 9, right? Those are equivalent fractions. They have the same value, but they look different, right? They have a different numerator, different denominator, but in terms of value, they are equal to each other. And the way we do that is that we just pick a number and we multiply top and bottom by the same number. We get our equivalent fraction, right? It's what we do when we reduce. If I have 20 over 30, when we reduce that, what does it reduce to? 2 over 3. But what you're doing is you're rewriting it as an equivalent fraction, just with smaller numbers. And to do that, you're dividing the top and bottom by the same number, 10. Okay? So we're allowed to change the way things look with fractions. And we want to change the way number 1 looks because the denominator is not rational. And so we can multiply the top and bottom by whatever we would like, as long as it's the same thing. Any good ideas to get rid of that square root of b? What could you multiply the square root of b by so that after I multiply it, I no longer have a square root? Square root of b. So what happens here is I get the square root of ab over the square root of b squared. And the square root of b squared is just b. And I have my answer. Okay. Rationalize the denominator. So there's no square root in the denominator now. There's nothing else we can do. You cannot cancel those b's out. Because one's underneath the square root, one's not. Okay. So number 3, we have 1 over the square root of a. We can't stop there because we have a square root in the denominator. So we're going to create an equivalent fraction, and we're going to decide what we multiply top and bottom by. What would be a good thing to multiply the bottom and top by to get rid of that radical? Square root of a. So we get 1 times the square root of a is square root of a. Square root of a times the square root of a is the square root of a squared, which is just a. And can I cancel those out? No. And number 4, what do you think we multiply by? Square root of 2 over square root of 2. We end up with the square root of 2 over the square root of 4, which is square root of 2 over 2. Number 5. Will you try number 5 and try number 6? With fractions, we're just thinking about stuff we've already known about fractions. We always reduce fractions. I just added a new rule. Can't have a square root in the denominator. That's the only new rule that we're working with. We also need to think about the rules that we've already learned, how to simplify radicals. So like when you get to 6, you may have to simplify some radicals. Give something to try. Okay, so number 5, you guys chose to multiply by square root of 7 over square root of 7, which really has a value of what? What's the square root of 7 over the square root of 7? 1. So you're multiplying it by 1, and whenever you multiply something by 1, it stays the same value. That's why we're saying that they're equivalent. We're just changing the way it looks. So 1 times square root of 7, square root of 7, square root of 7 times square root of 7, square root of 49. So we get square root of 7 over 7. Okay. When I get to number 6, okay, there's more involved here. And so I'm thinking about 3 things at once. I'm thinking about, okay, I can't have a square root in the denominator. I may have to simplify these, like break the numbers down like we've been doing and pull stuff out. And it's a fraction, so I may want to reduce, right? And reducing, if you can reduce, reducing is always the best thing to do first because it gives you smaller numbers to work with. And usually there's less work involved if you can reduce first. And so they're both square roots. And just like we go back to number one, right? We can go back and forth between a fraction of 2 square roots or just think of it as 1 square root with a fraction, okay? If you have a fraction on top and bottom, and that's what we have here. So we can think of this as the square root of 42 over 14. And by thinking of it that way, then I can think, well, I can maybe reduce that fraction. What goes into 42 and 14? 14? How many times? 3. So this is really the square root of 3, and I'm done. Now, some of you did it a different way, okay? I don't necessarily agree with that. Yeah. Okay. How'd you do it, Maddie? Did you say you did it wrong? Let's see. I don't know if I believe that you did it wrong. How'd you do it? Okay. So you got the square root of, okay. So you multiply top and bottom by 2. Okay. Nothing wrong so far. Okay, so why can't you leave it there? But what you could do, you know the square root of 4, so you could do a square root of 12 over 2, right? And that so that gets rid of the square root. So is this still the same thing as the square root of 3? It is, because remember, there's one more thing we got to think about. Can I simplify the square root of 12? And the square root of 12 is the square root of 4 times the square root of 3. Square root of 4 is 2. And now I can reduce it again, because it's a fraction. And I divide by 2, and I still end up with my square root of 3. So as long as you don't make a mistake, you can get to that square root of 3. The more experience you have, the quicker you can get there, right? And so if it takes you lots of steps to get there, and when I do it, it only takes me a couple steps, don't feel bad as long as you're getting there. And then the more experience you have, you'll learn what to do as you approach this. Okay. So number 7, what would be a good thing to do to start? Maybe simplify, like reduce it, reduce the fraction. Sure. Now we could rewrite it as a fraction of 1 square root, or we could just divide it as is, because we know it works. And so how many times does 12 go into 48? And so this one works out really nicely for us. How about 8? It's a good first step. Reduce. Always reduce if you can reduce first. So what goes into 8 and 98? 2 for sure. They're both even. So if I divide by 2, I get the square root of 4 over 49. Okay. And then what's the answer? Well, you can split it up like this, and that's 2 over 7. These are not too challenging. We're working out okay. 49. How do I get rid of? Well, what's the square root of 4? Square root of 4 is 2. Because what does the square root mean? Yeah, only. Because the square root's asking what numbers. This is asking what number squared equals 4. Answer is 2. This is asking what number squared is 49. Answer 7. All right, 1 over square root of 5. We've done stuff like this. What do we multiply by? Square root of 5 over square root of 5. So Maddie, can I take the square root of 5? Can I take the square root of 25? All right. So we get square root of 5 over 5. And we're good because there's no more reducing. No square root in the denominator. And I can't simplify this anymore. So there's 3 things I'm looking for whenever you're dealing with fractions. Can you reduce? Is the denominator rational? And if you have an irrational number, can it be broken up more and simplified or not? Okay. All right, I'm going to try to trick you on this one. But I know some of you I can't trick. So try number 10. Same rules, but now it's a cube root, so you gotta think a little bit more deeply on this one. Okay, try it out. Any ideas? So like that. Awesome. Awesome, awesome, awesome. That's exactly what I was thinking. Because we need 3 of them now, right? Because it's a cube root, so we're looking for sets of 3 things instead of a square root. And so in the top part, we end up with the cube root of 25. In the denominator, we end up with the cube root of, I'm just going to write 5 cubed, which is 125. But we have 3 of them. And so, can I take the cube root of 25? No. There's only 2 5s there. Can I take the cube root of 5 cubed? Yes, that becomes 5. Okay. And so the 3 things we look for is, we know we're done if the denominator is rational, and it is. It's a 5. Is it reduced? Can I divide 25 by 5? Might be tempting, but no, we can't, because that's not 25. That's the cube root of 25. And if you type in cube root of 25 into a calculator, you get this decimal value that's not evenly divisible by 5. Okay, so no, we can't. And then can I break that up and pull something out of it? No, because there's only 2 5s. I need 3 of a kind and to simplify that. Try 11. All right, so I want to hear again. What are we trying here? How do we end up with our goal where the denominator is rational? Anybody? I know Ashley's got an idea. Anybody else though? Morgan, got an idea? Okay, like that. And that's going to work. Good idea. And so when I do that, I should have made that 16, but that's okay. So I get that. Okay. Anybody stop there? Or should I keep going? Oh, okay, hold on. I want to hear the different way in a second. But if you went this route, how many went this route? Okay. Did you stop? How many stopped here? Okay. Don't stop here. Because remember, there's 3 things you got to check. 1, denominator rational? Yes. Check. 2, can I reduce? No. Can't divide the 7 by the 4. Those are the 2 things I'm looking at. This I got to stay away from because that's the cube root. But the third thing is, can I simplify that? And you can, because cube root of 16, 16 is, when you break that down, you get 4 2's, and you can get rid of 3 of them. And so this is going to really end up being 2 cube root of 2. So we got to keep working here. You get 7 times 2 cube root of 2 over 4. And you multiply 7 and 2, and you get 14. Cube root of 2 over 4. Can I stop there? Still something that we need to do what? Reduce the fraction. So when I say reduce, you're looking at the two numbers that are not underneath the square root. And you can divide both those by 2, and you get 7 cube root 2 over 2. You finally got there with that, lots of steps. Okay, but that's not the only way to do this. So we're going to look at another way. What did you try, Ashley? Okay, stop there. Can anybody see why she might have chose that? Why 2? What's that gonna, is it gonna work? What's gonna happen if we multiply these? What are we gonna get? Is that a good number? Well, I mean, the job is to get. Okay. 8 is a perfect cube. What happens when you break up the 4? You get 2 2's. So I think Ashley's saying, hey, we already have 2 2's. We just need one more. Does that make sense? So up here we said we got 1 4, so we need 2 more 4's. That's fine. But you can also break that number down and say, hey, what's that number made of? 2's. Got 2 2's. I just need one more 2. Right? Is that what you're thinking? Okay. So by doing that, watch what happens. Less work. Okay. This way wrong? No. This way shorter? Yeah. Okay. And that's why I say with more experience with this stuff, you start to learn how to get there. Okay. So try the 4th root of 5/8. And keep in mind Ashley's method there. It might help you here. So this one, it's not helpful to be in this form, so because I can't reduce the 5 and the 8, so I'm going to rewrite it as the 4th root of 5 over the 4th root of 8. Oh, thank you. I have 1 8. I need 4 things. I could choose 3 more 8s. That's a lot of multiplying, though. 8 times 8 times 8. That's a lot of stuff. So instead, I'm just going to break down that 8 and see what it's made of. And I get, oh, I already have 3 2s. And I would like 1 more of them. And so I'm going to multiply by the 4th root of 2. So whenever you can use smaller numbers, it's easier. Okay. And so we end up with the 4th root of 10 over the 4th root of 16. Or you could say 2 to the 4th power. And that's the 4th root of 10 over 2. Can I divide the 10 by the 2? No. Okay. So